Okay, hi. I'm Carlee, and we're going to be doing problem number 28, and the problem is y equals negative x squared minus 4x, and they want you to sketch the graph. Since this is a problem where you can't see any of the transformations, you have to find the vertex first. And the formula for the vertex is negative b, which is this term, over 2a, which is this term. And then to get the next term, you solve for y. So what you're going to do is take negative 4 over 2 times negative 1. The negative and the negative cancel there, and so you end up with negative 4 over negative 2, which is, no, positive 4 over negative 2, which is negative 2, and that's that. And so then you're going to have negative 2 squared minus 4 times negative 2. Negative 2 squared is 4 times negative is negative 4 minus negative 4 times negative 2 is plus 8, and you get 4. So your vertex you now know is negative 2, 4. And then from there, you can go ahead and start sketching out a rough graph in 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and go negative 1, negative 2, 1, 2, 3, 4, and plot your vertex. And then from there, make an x, y table. And you want to go to the right one x value and to the left one x value. So to the right one is negative 1. You plug it in. Negative 1 squared minus 4 times negative 1, negative 1 minus plus 4 is 3. And so you go over negative 1, not 3. Another way to do this is a parabola that just has 1 in front. It's known that a parabola goes from the center up 1 over 1, up 1 over 1, and so on and so forth. But since this is negative, you just know it goes down 1 and over 1. And so there you have 3 points. And if I can draw a straight line, you can just graph your parabola. And there you go.
Hey guys, it's Rachel. Today I'm doing problem number 35, which is a horizontal parabola. And this is the problem right here. And what you want to try to do is get y by itself. So this is what the parent function usually looks like. It's x equals y squared, and you want to solve or get y by itself, so it would be plus or minus the square root of x equals y, because you have to square root that too. And then, so you do the same thing with this. So first thing you want to do is add 1 to the other side. So you have x plus 1 equals y squared. Then the next thing to do is take the square root of both sides. So you have plus or minus the square root of x plus 1 equals y. And then from there, you graph it. So you have your normal square root, but it's x plus 1. So if it's with the x, you're going to move either to the left or to the right. But in this case, you're going to move to the left one. You do the opposite of the sign you see. So this is where it's going to start. Oh. Okay, so then if you don't know what other points to use, you can do x and y chart. And I'm just going to add some more lines over here. And with the square root, it usually only goes to one side. So I'm just going to do 0. So if you do square root of 0 plus 1 equals square root of 1, which is 1. So 0 up 1. Okay, so since you have that point, you can just mirror it to the other side because it's plus or minus. So I'm just going to put, it goes 0 and then down 1, and you can make your parabola.
Hi guys, it's Carlee again, and what we're doing now is number 45, And the problem is 2x over x minus 1, and they want you to sketch the graph. So with these, which are called rational functions, the best way to figure out what you're doing is to look at the parent function first. The parent function is y equals 1 over x, which has your basic graph, but because the denominator cannot be 0, you have asymptotes, which are imaginary lines you cannot touch, at 0. And then if you start plugging in values, like 1, 2, 3, etc., you'll learn that it never touches your axes, but it comes very close in both the first and third quadrant, and that's the parent function. And the way to figure out if your asymptotes have moved is to set the denominator, in this case x minus 1, equal to 0. And so x equals 1, there's an asymptote. And so you can pull your graph. And so now that we have x equals 1, just go to the right one and plot the line x equals 1, which is right there. And from here, you just go completely along with the parent function, except you have your other asymptote still at y equals 0, and you just don't touch your asymptotes. It's okay that you cross the axis and everything, and the top really doesn't make a big impact on it, and so this is your graph, and that's it.
Alright, hey, it's Rachel again. So now I'm on problem number 50, which is a cube root. So the parent function for a cube root is y equals the cube root of x. And usually this is what the graph looks like. It starts at 0. And if you don't know, you can always make an x and y table and plug in points to find these. But this is usually what it looks like. And it goes up that way and down that way. So that's what the parent function normally looks like. So on this one we're going to do the similar thing. We're going to make a little graph. But since this one, the 1 is paired with the x, you're going to move to the left one. And that's where you're going to start. That's where your vertices or your main point's going to be. Okay, so now you can make your x and y table, and you pick points to plug in. I'm going to pick 0 as 1, so you do the cube root of 0 plus 1, which you get cube root of 1, which is 1. So that's that, so you go over 0, up 1, and then I'm also going to pick negative 2, and I'm going to erase this so I have room. And I'm going to do cube root of negative 2 plus 1, you get cube root of negative 1. And in this case, it's okay to have a negative 1 because this is odd, so it's still going to be negative. Your answer, your y, is going to be negative 1. So you go negative 2, 1, 2, and then down 1. So this is going to be your graph.